Here's problem 2314. A particle, mass 5 grams, charged 40 millicoulombs, moves in a region of space where the electric field is uniform and given by E sub x is a negative 5.5 newtons per coulomb, E sub y is equal to E sub z is equal to 0. If the position of the and velocity of the particle at t equals 0 are given by x equal y equals 0 and v sub x equal 50 meters per second, v sub y equals v sub z equals 0, what is the distance from the origin to the particle at t equal 2 seconds? Alright, just this speaking of this problem is more difficult than it actually is. And we don't really need to talk about all this other stuff. Let's just get down to the basics here. And that is, we have an E field in the negative x direction, and we have initial velocity in the positive x direction, and we're given the mass and charge of the particle. So just to simplify this problem, we have an E field going this way. Magnitude is 5.5 newtons per coulomb, like that. Here's our particle. Mass of the particle, 5 grams. And charge is 40 millicoulombs. And then we have an initial velocity in the positive x direction, and that is equal to 50 meters per second. So we need to find the acceleration due to this E field and then treat this problem as a kinematics problem. That's how we deal with all these kinds of problems of this nature. So we have that the acceleration will be the charge to mass ratio times the E field. That's going to be 40 millicoulombs over 5 grams times the E field. And we're just looking for the magnitude here. So 5.5. 10 to the minus 3's cancel out. This is 8 times 5.5, which would be 44 meters per second squared. Alright, now we have our kinematics problem, where our initial velocity in the x direction is equal to 50 meters per second. Our acceleration is in the opposite direction, so acceleration will be a negative 44 meters per second squared. Our time is 2 seconds, and we want to find the distance of the particle from the origin after the 2 seconds. So in this case, everything's x direction, so we want to find displacement delta x. Well, that's kinematic equation number 4. Looking like this, and that's going to be equal to 50 times 2 seconds plus 1/2 times negative 44 times 2 seconds squared. So that's going to be 100 plus minus 88 plus a negative 88, or 12 meters. So after 2 seconds, the combined motion of the initial velocity and the acceleration will leave us 12 meters from the origin, a little bit longer, and we'll start going continue in the negative x direction. But right now we're at a displacement from the origin of 12 meters.